Okay, so the answer is C. So the answer is C. Let's discuss why. We can see that plutonic rocks have higher grain size. That is, they have higher crystal size. This is true. Earth crust is denser under ocean than under continents. This is also true. Acidic lava has more silica content, and granite is plutonic rock. So we have seen that the answer is C. Now let's see the classification of rocks. So there are different types of rocks. We already seen the igneous rocks. So now let's see the sedimentary rocks. So the sedimentary rocks are basically formed from sediments of other rocks accumulated over time. So we know that the rocks are broken down over a time due to weathering. So these smaller fragments of the rocks, they tend to accumulate in one place. So here we can see an example that the rocks will accumulate in this region over the time. And when they accumulate over here, layer upon layer will be formed, as we can see over here. So this is the first stage. Then we can see that one layer has been formed. Then further deposition of these rock fragments upon that layer will create another layer, and over the time we will see that there will be different layers, and because of the pressure and heat of the above layers, these fragments of rock, they will cement together. So rocks are formed from sediments of other rocks accumulated over time. The other rocks can include igneous, metamorphic, as well as sedimentary rocks. So all three types of rocks can lead to formation of sedimentary rocks. They are generally accumulated underwater. So most of the sedimentary rocks, you will see, they were formed when the region was submerged underwater. However, flows are example of the sedimentary rocks which are formed over land. Now, the characteristics of these sedimentary rocks are they are layered. So we have seen earlier that the igneous rocks are not layered, but here the sedimentary rocks are layered, they are stratified. Their layers could be few centimeter to few feet. We can see an example of a sedimentary rock, and we can see that each layer is pretty distinct because each of this layer was formed under different climatic circumstances, as well as they may have different source rocks. So that is why each of this layer is distinct from the other layer, which is visually recognizable, and that is why it is stratified. Non-crystalline. So here we do not see any crystal formation in the process, so they are not crystalline. They contain fossils because they are formed by deposition, and in this process, if some animal gets buried, then it remains, will be preserved, and that is why sedimentary rocks are best known for fossils. They can be hard to soft. So sedimentary rocks can be very hard, they can also be very soft. They could be coarse to fine grained. So if it is formed of clay, it would be fine grained. If it is formed of the pebbles or rock fragments, then it would be coarser. So the sedimentary rocks can be further divided into mechanically formed, that is formed due to weathering of rocks, organically formed where the sediments are given out by organisms, or chemically formed where the sediments which form these different layers, they are created by a chemical reaction. So mechanically formed are formed from accumulation of rock fragments of other rocks cemented together. So here we can see an example. Here we have these small rocks, and all these rocks over the time have been cemented together. So this is a mechanically formed sedimentary rock. Sandstone is an example. Sandstones can be of various types. So this is basically that sandstones can be of these types depending on the size of the particles which make them. If it is coarser, then it is called grit. It is coarser type of sediments. Conglomerates are rounded pebbles. They are something like this. Breccia rock fragments are angular, so they are not smooth curved. They have these angular regions, and then clay, finer sediments material. So here we can see some different types based on the grain. So coarser sedimentary rocks are on this side, and fine grained sedimentary rocks are on this side. Sedimentary rocks organically formed. They are formed from the remains of living organisms such as corals or shellfish. So we see that the sedimentary rocks can be formed by uh, organisms, and when they are formed by different organisms, then it is called organically formed. Example are calcareous rocks, which includes limestone. So see, limestone can be formed chemically, they can also be formed by a deposition of corals. That is why it can be both chemically formed as well as organically formed. Carbonaceous rocks formed from vegetative matter. So in the carbonaceous time, the vegetative matter, they got submerged and they led to formation of sedimentary rocks. So they are also example of organically formed sedimentary rocks. So the fossils of the animals, which when they form this type of rocks, they can be called organically formed. Pressure of overlying sediments cause plant remains into compact mass of carbon. Here we can see an example. This is the region, and if suppose there are this organic matter of peat, and then sediments are deposited, so this peat, it gets compressed. Now there is very high pressure and temperature, so over the time it will get converted into lignite coal, and if sufficient time is available, sufficient pressure is available, then it can be converted into bituminous coal. So we can see that this is how the organically formed, that is the organic matter, is converted into sedimentary rock. Then we have this chemically formed sedimentary rock. So suppose there is this water, there is this lake, or there is this pond, very big pond, and now there is this evaporation. Now because of the evaporation, some of the minerals in that lake or water, they will start to become concentrated, and then they will start to do some crystal formation. They will start to concentrate and lead to crystal formation. Over the time, we will see that the water content is falling and the crystals are increasing. There will come a time when the lake water is completely evaporated and there is a very thick layer of these type of rocks. So this is how chemically sedimentary rocks can be formed. So they are formed by chemical precipitation from solution. Example, rock salts derived from beds of seas or lakes. Gypsum obtained from evaporation of salt lakes having high salinity. Example, Dead Sea. Even in our Rajasthan, gypsum is found because of the lakes which were there earlier. They evaporated, leaving behind the gypsum. Potash and nitrates are also formed in similar way. So we can see rock salts, gypsum, potash and nitrate. They are basically sedimentary rocks formed by chemical process. Now if you guys are online, if there is someone available, so here is another question. Again the same process, I will initiate the poll. You will see the poll options here, then only go for the option. So the question is, which of the following statement is true? Volcanic rocks do not have layers. Sedimentary rocks have layered structure. Coal is a sedimentary rock. Sedimentary rocks can be formed by a fragment of broken rocks. Let's see. So here is the poll, and you can now type in your answers. Whatever answer you believe is right, you can just type in the chat. And we will see in 1 minute what is the right answer. Volcanic rocks do not have layers. Layers, we have seen that it is different rocks having very recognizable layer. And then is coal a sedimentary rock? We have already seen sedimentary rocks can be formed by fragments of broken rocks. So our time 10 seconds is left. Let's see what happens after 10 seconds. So let's see, the answer was B. So let's see, volcanic rocks do not have layers. We have seen in previously that volcanic rocks do not have layers. It is the sedimentary rocks they have layered. That is, the sedimentary rocks are stratified while the volcanic rocks are not stratified. So 1 is true, 2 is also true. Coal is a sedimentary rock. We just saw that this is organically formed sedimentary rock. And sedimentary rocks can be formed by fragments of broken rocks. So this is the example of mechanically formed sedimentary rocks, where the rocks were formed by the broken fragments of the rock which existed earlier. That is why all these statements are true and the answer will be D. Now let's see the third type of rock, that is the metamorphic rock. So all types of rock, it could be a metamorphic rock, it could be an igneous rock, or it could be a sedimentary rock. So these rocks within our earth crust, they are subjected to high temperature as well as high pressure. How does this high temperature come upon? As the depth increases, the temperature increases, as well as the volcano, when it brings the lava to the surface. So the regions which are adjacent to this lava pipe, they are also subjected to high temperature. Pressure also increases with the depth of our earth. Moreover, the regions where there is this plate margin, there is also high pressure and temperature because of the friction. Because of these conditions existing within our earth, we see that the rocks which are present in this region, they change their characteristics without getting melted or without being molten and resolidifying. So remember, a metamorphic rock never gets melted away and then reformed. So that is a different thing. That would be an igneous rock. Here the rocks never melt. Within the solidified form, their chemical properties change in the metamorphic rock, and that is why it is called metamorphic rock. So here are certain examples. Clay, when it is subjected to high temperature and pressure, it will form slate. Limestone, when it is subjected to high temperature and pressure, it will form marble. So see, marble is basically formed from a sedimentary rock. Now marble is a metamorphic rock. This is a sedimentary rock. Sandstone is converted to quartzite. So here are further relationship. You can see granite is an igneous rock which is converted to gneiss. So any type of rock can be converted into metamorphic rock. Remember that metamorphic rock does not mean that the rock which existed earlier, it gets molten away and then that melted part is resolidified. That is not metamorphic rock, but metamorphic rock is that within the solidified form, the rock will change its characteristic. Again, there is again a question, again the same format, we have 4 options. A metamorphic rock cannot form another metamorphic rock. This is the first statement. Pressure alone cannot form metamorphic rock. So it says that if there is only pressure and no temperature, then no metamorphic rocks can be formed. Then there are these 2 examples. Diamond is a metamorphic rock. Dolomite is a sedimentary rock. So there are these 4 statements. Let's see, let's start. Here is your poll and you can choose whatever option you feel is the right option. We have discussed these 2 just a few minutes ago. In these 2, we have not specifically mentioned, but you have to think about it whether dolomite is a sedimentary rock or not, whether diamond is a metamorphic rock or not. So a metamorphic rock, we have seen that it is the rock when it changes its characteristics without getting melted. And a sedimentary rock is a rock which is created layer by layer. Okay, so the answer is D. Only 3. The third statement is only the right statement. So metamorphic rock can form another metamorphic rock. Pressure alone can form metamorphic rock. So therefore these 2 are wrong. Diamond is basically a mineral and not a rock. So even this 4th statement is wrong. Only the 3rd statement is right. Therefore we can see that the answer D is the right option. Now let's see Earth's movement and major landforms. So the appearance and characteristics of a region depend on the underlying rocks. So what kind of landform is formed in a region, it will depend whether the rocks are soft or hard, or what is the history of the tectonic activity or other natural forces acting on those regions. If there are softer rocks, they are easily weathered away. If there are harder rocks, they will take a lot of time. Landforms on Earth are shaped by agents of denudation and weathering. So basically, this is the weathering. That is, we have our water, rain, frost, wind, glaciers, waves. So what all these exothermic or external forces, what they do is that they will shape the region. They will cause erosion and deposition. So if, for example, here are the mountains. So over the time, they will erode these mountains and then they will form a plain region. So this is how they will shape the region. For example, if we see our Gangetic plains, so they were formed because of deposition of the rocks which were eroded away from Himalayas. The erosion, they acted upon the Aravalli mountains and they lowered their height, and whatever was eroded away, they got deposited in the surrounding area. So in the one place it reduced the height, in another place it increased the height. So they modify the pattern of mountains, plateaus and plains created by movements of earth crust. So even the earth crust movement, they also create certain landforms. Here we can see there is an example over here. Here is our two plates, both are of continental plates. So we can see that when this plate is moving here, we can see that the landform on the surface, it is getting deformed and we see some mountain formations. Here also we see that there is some deformation created and some type of plains or some type of plateau or mountain will be formed in this region. So this is how the movement of the plates, they create landforms in the region. Earth movements build landforms on the earth which are worked by force of denudation. So basically the internal forces, they will create these kind of mountains or plateaus or even some kind of other landscapes, and the external forces like the glacier, water, earth, what they will do, they will try to erode them and flatten them out. So this is how the landscapes are formed in a region. So over our history of Earth, there have been several occasions when there have been some forces which led to creation of these mountains. Now there are some debates, but 9 major orogenic events, that is the mountain building movements, have been recognized over the history of Earth. So they have been categorized into 9 major events. Some of them, that is most of them, actually occurred in Precambrian period, that is more than 600 million years ago. So this is way before formation of Pangaea. We know that all the earth was once situated together, which was called Pangaea. But these occurred way before Pangaea, so we are not going to see them. The most recent ones are Caledonian, which occurred around 320 million years ago. And it occurred in this region where there was this Europe and North America, they were together. So in this region there was a lot of areas where this Caledonian uplift created mountains. Here we can see that it is indicated by this green color, so you can see mainly the North England and this Norway, and you will also see some parts in the American continent, even in Greenland were created because of this upliftment. So Scandinavian and Scotland mountains, mountains of North America were created. Then there is this Hertzian orogeny which occurred around 240 million years. Ural mountains, Pennine, Welsh Highlands of Britain, Harz mountains, Appalachians of East America, and high plateaus of Siberia and China. So all these were created during the Hertzian upliftment period. And then the most recent one is the Alpine one, which is named after the Alp mountains. And here we can see the extent of the Alpine Himalayan orogeny belt. So during this period, not only the Alps, Himalayas, as well as Rockies and Andes were also formed. So all these formations occurred in the Alpine time era, or in this orogeny, which occurred around 50 to 30 million years. So all these years are basically an estimate. We will see slightly variation in different books, but they are mainly classified into these 3 groups. So now let's see the different types of mountains: fold mountains, block mountains, and volcanic mountains. So the mountains which are formed on the surface of the earth, they can be classified into these 3 types. So what are fold mountains? When 2 plates, they collide, there is compressional force. See, this plate is moving towards this plate, so there is kind of compression. Now when this happens, the denser plate, it tends to move downwards, but in the crust or in the upper part, we will see that these wrinkles are formed, or there is this folding of the crust. Now here, because both of them are continental crust, and remember continental crust is less denser, so it does not subduct. The mantle is subducting, but the crust will not subduct. There will be these foldings, and they will lead to formation of mountains like our Mount Everest, like our Himalayas. So the mountains which are formed by folding of the plates, they are called fold mountains. The folding shortens the earth crust. Remember earlier this earth crust was stretched, but because of these compressional forces, we saw that the total length of this earth crust, it was shortened because a lot of them have been folded and uplifted. So vertical extent has increased, but horizontal extent has shortened. That is why folding shortens the earth crust. Waves are formed. Upfolds are anticline and downfolds are synclines. So the upfolds are anticlines and these downwards are synclines. Compressive forces could form tectonic movements caused by magma flow in asthenosphere. So this is our asthenosphere, and there would be magma flow in this asthenosphere, which could lead to these compressive forces. The compressive forces can also be formed by contraction or expansion of earth crust. So the earth crust can also undergo expansion. If you have known about the basin region of United States, so here there is the expansion of the continental crust, increased load of overlying rocks. Now this is related to isostasy. So if the loading increases, for example, if there is a higher amount of loading in a region, then the isostasy will be changed, and that could also lead to some form of compressive forces. So now let's try to understand what kind of folds are there. There are a lot of types of folds, but here mainly three types of folds are discussed in GC Long. So overfold. Now overfold is shown over here. What happens that in normal fold, our earth, the plate of the earth, it just moves up. In asymmetric, we will see that this anticline, this upper part is slightly on one side, but in overfold we will see that it has gone beyond. There is a high inclination and it is bent like this. So that is called overfold. The axis is very inclined, but when it comes to recumbent fold, we will see that this would almost touch it, and this plane is horizontal. The fold plane becomes horizontal, that is parallel to the surface over which it is there. And then comes the overthrust. Here we see that because of the continued compressional forces, a fault is created. And now we will see that this region of the plate is moving above this plate. So now there is this fault created, and this region is now forced on the other part. So here is overfold, recumbent fold, and overthrust. So this is basically increasing in the compressional activity. Recumbent fold, overfold, if pushed further, becomes recumbent fold. So overfold, if it continues to experience the compressional forces, it will form recumbent fold. Overthrust fold, if forces continues, that is in the recumbent fold, if it continues, fractures occur, upper part of recumbent fold slides forward. We can see that this part is sliding over this part, over the lower part along the thrust plane. Nappe is an example of this, where you will see that large parts of a region are actually uplifted because of this, or they are lying over another region. Fold mountains are closely associated with volcanic activity. Here we can see Circum-Pacific fold mountain system. So this is the Circum-Pacific. We can see the part of this Pacific on this side, as well as this is the part of Pacific. These triangles, they show the volcanoes, and we know that here we have Andes mountains, here we have our Rockies mountains. So we can see that these Rockies mountains and Andes mountains are closely associated with these volcanoes, and the reason why there is so much volcanism in this region is because the oceanic plate is subducting under the continental plate. Here the Pacific plate is subducting under the North American plate, and here there is this Ch2 plate which is subducting under the South American plate. And similarly here also we will see that there are different plates which are subducting. So because of that, volcanoes are formed along these boundaries. Here in this particular example, we are seeing continental plates. So when the continental plate meets, you will see that volcanoes are generally not formed because the crust, it never reaches the deeper parts of it never subducts actually, and that is why there is no melting of the crust to form the magma. Remember, in these volcanoes, the magma does not come from asthenosphere, it comes by melting of the crust. So here, since the crust does not subduct to the depth and it does not contain a lot of moisture or a lot of water, therefore it does not lead to formation of magma, and that is why here in the Himalayas, even though fold mountains are there, we do not see volcanoes in this region. So when there is this continent margin, volcanoes are generally not formed. When there is this oceanic and continent boundary, volcanoes are generally formed. Circum-Pacific fold mountain system, it has a lot of volcanoes, contain rich mineral resources. So here you will see that there are a lot of mineral resources, specifically in the mountainous regions you will find like they are mineral rich, right? Like our Ch2 plateau. So the reason is that the deeper parts of our earth, they have heavier elements. Now during all these processes, deeper parts of rocks, they come to the surface, and over the time they are eroded, the surface is exposed, and we have access to these rocks. That is why generally the mountains or the plateaus, you will see that they have very rich source of minerals. Now let's see the block mountains. So earth crust bending causes fold. We saw that when there is a lot of elasticity in the plates, when they are colliding, then they will lead to formation of folds. But if there is faults, if there is no elasticity and the earth crust, it cracks up, then it will cause faults. And here are these examples. Here we can see the compressional force is there. Forces is acting, it is creating a compression. Here there is this what we call as tensional force. It is moving away, it is trying to move the block, it is trying to stretch the block. And here we can see that there is combined effect of all of these things. Here we see that it is also stretching, and we will see formation of block mountains in this. So if I run all of these three videos, you can see that because of this compressional force, a fault is created, and along this fault, this is sliding up. Similarly here, there is this normal fault, and this part of land block is moving downwards. And in this, which is our landform, if we see because of tensional forces, we see that one part of the landform, it can move downwards, while the other part could remain at its position. And we can now see that there are very steep slopes and mountains are formed because of this kind of movement. So these kind of mountains, where a part has got subducted or it has got downward, it has created these kind of valleys. So that is called block mountain. Our Western Ghats as well as our Vindhyas, especially our Western Ghats, they are example of block mountains. Vindhyas have characteristics of both. Some parts have gone this downward movement. The Narmada Valley and the Tapti Valley are basically the rift valley which are created by these kind of faulting. So they also show signs of block mountains, but they were created initially due to the folding, due to collision of blocks. So initially they were formed as a fold mountain, but because of these faulting and other things, formation of those river valleys, they have these block mountain characteristics. The faulting caused by compressional forces shorten earth crust. So we can see that because of the compressional forces, we can see that this is moving up and the total length of the earth crust is decreased, while the tensional forces, when they stretch the region, we will see that the length of the earth crust increases. Because of above, a section of earth crust may rise or fall. So we can see here that a part of our earth can rise or fall. So here it is rising up. This is called reverse or thrust fault. Here it is going down. It is called normal fault. Here we are seeing example of normal fault, that these part of graben are moving down while the host, they remain at their location. Here we can see host or block mountains, parts rising up. So here, because it is a tensional force, so it is not rising up, it is stationary at its position. Graben or rift valley, parts moving down. So here the graben is there, which is moving down. And because of that, we are getting the mountain-like structure. If you are located in this valley, you will feel that this is a long mountain. So block mountains are created by generally by tensional forces pulls the crust, creating faults. We saw that it will pull the crust and form these faults. Then there will be some part of the block will move down, some will move up, and it could create mountains. Host of block mountain, land between the fault rises up, land between the fault stays, but surrounding region falls. So these are two processes. Either the land part should rise up or the surrounding land should move down. Then we will have this block mountain. Characteristics of block mountain: very steep slope. So we can see here, because a part of is moving down, so the part which is remaining up, it has a very steep slope, as you can see over here. Vertical steep slope, summit is also flat. So we can see that here the summit, that the top of the mountain is flat. Now in the fold mountains, generally the top is not flat, but here we can see that there is large plain region, so it can be taken as a plateau. There are certain examples of this. This is Black Forest of Germany, which is in Rhineland area. So that is an example of a block mountain. Here we can see the snapshot of that region. This is the Black Forest, this is a mountain. Here is our Rhine river, this is Graben. This is Graben, right? So the part which has moved down. So here we can see Rhine, Graben, Rhine river flows through this part, and then we have another mountain which is Vosges. So these all three, they create the example of block mountain. So we have seen that tensional force pull the crust, creating faults, Graben, rift valley. So earlier we have seen about the host. Now we will see that rift valley region between the faults moving downwards. So the rift valley is basically the region which is moving downwards, and so another way of forming a rift valley is that region is stationary but surrounding region moves up. It can be formed in both these ways. And what are the characteristics of rift valley? Again, it has very steep slopes. Example, East African Rift Valley. So here we know that this side of the African plate is moving away from this side. It is creating a rift within the continental landmass, and because of this rift there is a rift valley, and the slopes are very steep on either side. So if you see actual photos of this region, you will find that there are regions where there is very steep slope along this margin, and there are a large number of lakes in this region. Compressional forces. So far we have seen that the block mountains were created by the tensional forces, but compressional forces can also create the block mountains through reverse fault, which is an example over here. Here compressional forces creating the block mountain. Block of earth crust may be raised or lowered because of the compressional force. However, most of the time the block mountains are formed by tension rather than compression. Now, volcanic mountains are also an example of mountains. So these are the mountains which are built from materials ejected from the earth crust through a volcano. So it mainly consists of molten lava, the lava which comes out and pours on the surface of the earth, cinder. So these are basically rock fragments, ashes, dust, mud. So all of these things, they are thrown out when a volcano erupts, and all of that, they accumulate, they cool down, and they form a landform. Here we see this mountain. So this mountain is basically formed of all these things. The materials accumulated around the vent to form mountains, called mountains of accumulation. It is called mountain of accumulation because they are formed by the accumulation, by the collection of all these items. There are a lot of volcanic mountains. Mount Fuji of Japan is a very good example of this. There are these other examples. here is a question once again. So let's see, there are certain statements, and you can based on which statements are true, you can select the option over here once I initiate the poll. So let's see the options first. Block mountains can be created by compression and tension forces. Recumbent folds are folds formed by fractured block or rock pushed over other block of rock. Block mountains have plain top. Black Forest of Rhineland is example of block mountain. So here is the poll, and if you want to choose an option, you can write exclamation OPT, and then you can write the option, whichever option A, B, C, D you feel is right, which of the based on the statement, then you can choose them and you can input here. So it will be exclamation OPT your option. So for example, if you feel that B is right, then you can use this example, exclamation OPT B. If you want to choose C, then you can replace this B by C. And similarly for A and D, we can replace these characters and they will give you the right answer. There are 18 seconds remaining for this poll. After 18 seconds, we will see what is the right answer, and then we will quickly discuss the answers. So the answer is B. B, we see 1, 3 and 4. So block mountains can be created by compression and tension forces. We already seen that both of these forces can create block mountain. Recumbent folds are folds formed by fractured block. So remember, this is not recumbent fold. This is an example of overthrust fold. So that is why this statement is wrong. Block mountains have plain top. We have already seen that the summit is plain. Black Forest of Rhineland is an example of block mountain. We have already seen that. Now let's see the types of plateau. The plateau can be divided into tectonic plateau, intermountain plateau, volcanic plateau and dissected plateau. So let's see each of them one by one. So what is a plateau? First of all, plateau is an elevated area. We can see here an example. This is the surrounding region, and this region, it has a flat top and it is elevated from the surrounding region. So unlike a hill, which generally does not have a flat top, a plateau will have a flat top, and that is what distinguishes it from a mountain. The plateau are elevated uplands with extensive level surface. This level surface is the important characteristics of a plateau. They usually have steep slopes. Here we can see that the slope is very steep. They are also called tableland. Tableland because they look like a table. Here you can consider this is one leg, then this is the flat top of the table, and then there is this other leg. So because it looks like a table, that is why it is called tableland. Are subjected to erosional process, alters original characteristic. So sometimes the plateau can be formed by tectonic activity, by upliftment, and other times a mountain can be eroded over the time to form those plateaus. So that is why plateaus can be formed by erosion or by upliftment. Plateaus are deposits of minerals. So we have seen that there are so many plateaus which are good source of minerals, like the African plateau is source of gold and diamonds, copper, magnesium, chromium. Brazilian plateau, huge resources of iron and magnesium, particularly this Minas Gerais area. Then there's this Deccan plateau. We know that Deccan plateau is also good source of minerals. There is also this iron and coal fields are there in Karnataka. Then we have even the gold mine was there. Even our Chhattisgarh plateau is also a very good source of minerals. Plateau of Western Australia. So all these plateaus are good source of minerals. Generally, they are good source of minerals because the plateaus are generally eroded by the mountains, or even when uplifted, the rocks from the deeper parts of our earth, they come up, and generally these rocks in the deeper regions of our earth, they have heavier minerals, and that is why when these regions, we find that there are good source of different minerals. So first is tectonic plateau. They are formed by Earth's movement. Earth's movement includes both the faulting as well as the tectonic movement. So both of these movements, they could create uplifted part. Here we can see that this is the uplifted part, so this could be considered as plateau. Here we will see that because of the movement of our one plate under the other plate we will see some foldings or some region is uplifted, like our Tibetan plateau. So because of both the folding or as well as this tectonic movement as well as the creation of the faults, we can see that plateaus can be formed. They are generally large in size. They are large in size because a larger region is uplifted or moved downwards. So because of that, a larger region upliftment or a larger region subducting down, we have these plateaus of very large region. They can include continental blocks, so they can be spread over a continental block, that is a very large region, and our Deccan Plateau is an example of this, where whole of our southern peninsula is a plateau. So they can be included over a continental block. They may be tilted. Even our Deccan Plateau is also tilted. We know that the western side is higher, the eastern side of Deccan Plateau is lower. So they could be tilted. Here is an example given in GC Leong, the Iberian Plateau. There is a specific plateau in this region which is tilted. They can be faulted. So that plateau can have different faults within that plateau. So here is an example of that. Now there is this intermountain plateau. What is intermountain plateau? So a plateau which is surrounded by mountains from all sides. Here we can see the Andes mountain, and this is on the western side of this South American continent, and here we can see Bolivian region, and this is the Bolivian plateau region. In the center we can see that there is this level area which is higher in elevation, but it is surrounded by mountains on all of these sides. So this is called Bolivian plateau. Here is the top view. You can see that this whole region is significantly plain, but it is surrounded by mountains on all sides. So this kind of plateaus are called intermountain plateau. There are examples: Tibetan plateau, Kunlun plateau, Bolivian plateau. All these are examples of intermountain plateau. Then we have volcanic plateau. Volcanic plateaus are basically formed by volcanic activity. So they can be formed by explosion of volcano, or they can be caused by this flood basaltic eruption, like in our Deccan Traps. So Deccan Traps are basically example of volcanic plateau where lava, it pours layers and layers and it lifts the region. So this is also flood basaltic plateau, and this is normal volcano which erupted and created a flat surface, so leading to a plateau. So formed by molten lava spreading over surface to deposit sheets of lava, solidified to form lava plateau. So the lava deposited on a region by different eruptions, and over a time it cooled down to form sheets of land. Antrim Plateau of North Ireland is example, northwestern part of Deccan Plateau, that is the Deccan Traps. So remember, Deccan Traps are a smaller part of Deccan Plateau. Deccan Traps are mainly found in Maharashtra and adjoining regions like Madhya Pradesh and Karnataka, but mainly concentrated in the Maharashtra region of Deccan Plateau. So the Deccan Traps are example of the flood basaltic type of plateau. Colombian Snake Plateau, each layer of the lava flow is over 100 feet thick. So you can see that these layers could be thick. But remember, the igneous rocks does not have layers. We have discussed earlier that they do not have layered structure. Now we have the dissected plateau. Now here we can see an image of a plateau, and earlier this was one continuous plateau, but over a time, due to different erosive actions, gaps were produced. Here we can see an example over here. So suppose this is a plateau which is a continuous block, and over a time, because of erosion, gaps were produced and they got broken away. So these are called dissected plateaux. These are extensive plateaus worn down by erosion and weathering. Surfaces of the plateaus are made irregular blocks. So this was one continuous block, but over a time it was divided into different irregular blocks. So we can see that these are now distinct irregular blocks. In humid regions, streams, that is water which is flowing, river waters, they can cause this dissection. In cold region, glaciers can cause the dissection. In dry region, rivers and winds can cause. Dissected plateaux have irregular surface, steep-sided slopes. We can see they have steep-sided slopes, mesa and but intersected by deep canyons, common in southwestern USA. So these are also example of dissected plateau. They are generally created by erosion of hills but in certain circumstances they can be called as plateaus. Now here we can see a summary of the process of formation of different types of plateaus. So here we can see faulting. So here we can see there is this magnetic plume which is coming from deeper part of the mantle, and it will cause bending of the plate of the earth crust, and over a time cracks can be formed on the edges. So the basin region of US is formed by this kind of faulting. Here you will see that the plate will move away. This will call crustal expansion, and because of this crustal expansion there will be faulting in this plate over here. Another is tectonic activity. We have seen how Tibetan plateau was created because two plates, they collided with each other. Here we can see an example. This plate moved over the other plate and uplifted region was formed, which is called plateau. Then we have example of Deccan traps. What can happen, that mantle plume which could come below the crust and cracks will be formed, and then slowly this lava or magma will seep on the surface, creating a plateau region. So remember the hot spot over the Reunion Island, it created our Deccan traps. Then we have this lava plateau. So here we can see that lava mantle plume again coming up, forming a volcano. Volcano emits the lava and it forms a continuous the seeds of solidified crust or solidified earth over here. So this is also a plateau. So this is volcanic plateau. So this is how different types of plateaus are formed. Here you can see by expansion, thermal expansion and uplift, crustal shortening because of tectonic activity, upwelling through crustal cracks, outpouring from a volcanic mountain. Here is a question for you. If you are watching this stream, you can read those statements and based on that you can choose an option. So I will start the poll. Yeah, here is the poll active. If you want to choose any of these options, you can choose those options. The first is plateaus are formed by upliftment and never by erosion. Intermountain plateaus are plateaus located at the base of a mountain. That is, intermountain plateau is located at the base of the mountain. That is what the statement says. Deccan traps are example of flood basalt plateau. So we know Deccan traps are different than Deccan plateau. Deccan traps are the western part of Deccan plateau. Deccan plateau is basically the whole of our peninsular plateau. Deccan plateau is example of uplifted plateau. Sorry, dissected plateau are example of uplifted plateau. So whichever statement you feel is right, you can choose that option. You can use exclamation OPT, and then for in this region you can write either A, B or C or D. So for example, if you want to choose B, you can write exclamation OPTB in the chat and your option will be selected. The right answer is D, and D says that Deccan traps are example of flood basalt plateau. This is the only right statement. Why? Because dissected plateau are not example of uplifted plateau. They are basically erosional plateau. Plateaus are formed by upliftment as well as erosion. So erosion can also form plateaus. Intermountain plateaus are not located at the base of the mountain, but they are actually surrounded by mountains. Now moving on, let's see different types of plains. So the plains can be classified into different types: structural, depositional and erosional. So structural plains, depositional plain and erosional plain. Depositional plain they can be wind deposited, glacier deposited, wave deposited, water deposited. Erosional plains can be wind erosion, glacier erosion, wave erosion and water erosion. So here we will see the examples of this in very short. In the upcoming videos there is very detailed chapters which indicate each of these types of erosions and deposition. So in that we will see that in very deep. So what are types of plains? So what are plains? First of all, plains are lowland, either level or undulating, may have rolling topography. So this rolling topography you might come across the NCERTs as well as the GC Leong. And what is this rolling topography? So if you see this example, here we can see that this region has very small up and down landform. Here we can see it is slightly up and then again down. So we cannot call them hills. So these are plains, but this kind of topography is called rolling topography. So the plains may have rolling topography, that is small hills. Even they are not actually called hills, they are called just rolling topography or rolling plain. Plains often intensively cultivated. So because they are plainer region, it is easier to cultivate, it is easy to irrigate, it is easy to transport. That is why they are intensely cultivated. There is high population and settlement concentration in these regions because of, again, ease of transportation, ease of agriculture, and ease of building houses and materials, moving it from one place to another. That is why a lot of population concentration is seen. Extensive grasslands can be found here. So the plain regions, they also have extensive grasslands. They are examples of Russian steppes, North American prairies, and Argentinian pampas. So these are the regions where you see that this kind of short grasses, they naturally grow over there because of the environmental conditions. Now let's see what are structural plains. So structural plains are formed by upliftment or subsidence of Earth's crust from tectonic activity. We have seen faulting as well as folding. These are the two important characteristics. And because of this, what can occur, that large chunk of landmass, they could be uplifted or they could be subsided. And because of this, we will see that the plain region can be formed. So here we can see that because of this structural faulting, this whole region will move downwards and there will be planed surface over there. So this could be form a plain region. Moreover, in the upliftment process, what happens that sometimes during the folding, a large block of region could be uplifted as is. For example, if you see Kashmir Valley, you can consider that it is located within the mountains, but it is a plain region which is uplifted. There is some depositional activity that occurred over here which created a plain surface. Similarly, you can consider that there, because of this folding, a region is formed at some locations which are plain. They are uplifted, but they are plain. So even the folding can create plain regions, while the block mountains can also create the faulting can also create the plain regions. So these kind of plain regions are called structural plains because they have been created due to faulting or folding. Formed by horizontally bedded rocks. So because they are moved up and down, so here we can see that if this region forms a plain, so here you can see that the rock bed, it remains as is, it is horizontal. So it is formed by horizontally bedded rocks. Rocks are undisturbed by crustal movements. So here we can see that all these rocks, though they moved downwards, they were undisturbed by the overall crustal movement occurring there. Russian platform is an example. Great Plains of USA, central lowland of Australia are example of structural plains which were created either because of faulting or folding, where a large region could experience folding. Even our Gangetic Plains, because of folding, there was this large depression created and it was filled with sediments over the time. So both erosion and this folding, they created those plains. Depositional plains. Now here we can see the example of our Gangetic Plains. So here we can see that because of erosion, which brought the sediments in this area where there was this depression, so we got a plain region. So Gangetic Plains are a good example of depositional plains. Plains formed by deposition of elements brought by agents of transportation. So here we can see rivers, but it could be glacier as well as wind or waves which could bring the sediments and deposit in a region. They are generally level with gentle rise towards adjacent highland. So here we can see that they are almost earlier there would be like large depression like this, but over time when the deposition occurs, we will see that the slope on both sides is very gentle. So consider these as Vindhyas, consider these as Himalayas. So we can see that the slope is now gentler. Partly depends on the source of sediments. So if the sediments which are coming from the region which has good amount of minerals, then it will be fertile region. If it is not, then it will be not a fertile region. So it depends on the source rock. Rivers form large depositional plains. Erosion by rivers in upper course. So rivers, when they flow in the upper course, like here, because of high slope, they will create a lot of erosion. They will gather a lot of fragments of rocks along with them, and they will carry them towards the lower course of those rivers and deposit them, because in the lower course they will not be moving with high velocity, while here they will be moving with high velocity. So the rock carrying capacity or load carrying capacity is higher in this region. Here the load carrying capacity is low. Therefore, they will deposit and they will form a plain region. Erosion by rivers in upper course, alluvial brought to lower course and deposited, forms alluvial plains, flood plains, deltaic plains. So these are the examples. Most productive plains for agriculture. So some of these depositional plains are the most productive plains, like Nile Delta, Ganga Delta and Hawango Delta. Again, another example of depositional plains is the glacier and ice sheets. The glaciers, when they flow, they come to a region where they start melting. Now, we will see in the glacier erosion chapter that these glaciers, they collect a lot of sediments, they cause a lot of erosion, and they bring those sediments along with them in the lower region. And then when it melts, those sediments or those fragments, they deposit. And over a time, because of this deposition, you will see that plain regions are formed. So, deposit widespread mantle of unsorted fluvial glacier sands and gravels in outwash plains. So, outwash plains would be this region. It is the region just after the glacier. So, when the glacier starts to melt, the fragments of the rocks in the glacier, they will flow along with that water and will be deposited in this region. So, this will be formed as a plain, which is called outwash plains. Drops, glacier till or boulder clay, mixture of boulder and clay. So these depositions, they will have smaller fragments as well as large rocks, because the glacier has very high carrying capacity. They can carry big rock fragments, and that is why the depositions here you will see will be a mixture of boulders as well as clay. Forms steel plain or drift plain. Outwash plains generally barren. Generally these plains are barren because the deposition are rock fragments and they are not fine clays. Because of this mixture, it is difficult for vegetation to grow. Boulder clay may be fertile at some regions, depending on the source of those depositions as well as the environment, they could be fertile. Again, in the coastal regions also we see example of depositional plains. In coastal regions, waves and winds, they carry beach materials deposited in coastal plain, form marine swamps and mud flats, tidal and estuarine lowlands. So what happens? The waves and the winds, remember the waves will depend on the winds. So basically the wind direction decides the wave direction. Now what happens? Suppose the waves are moving like this. So they will carry particles towards the coast and they will deposit in the region. They would form this kind of beach over here. So this is source aligned, that is the waves are aligned with this coast here. But here we can see that it is not aligned. So because it is not aligned and the waves are basically longitudinal, what will happen? The sediments, they will be deposited in a longitudinal direction. But because of gravity, over the time it will move down again. So you can see it is deposited because of the waves. But because of gravity it is coming down. Again because of waves it is deposited in this direction. Then because of gravity it is moving down. So this process continues until it reaches here. And then it starts to deposit over here. So you see that an extension is formed. This is a depositional plain formed by waves. So we will see this in detail when we are studying about coastal landforms, which is like chapter 10th. So examples are coastal lowlands of Belgium, Netherlands, Gulf Coast of USA. Emergent coastal plains. Tectonic activity may raise a portion of the coastal lowland. So what happens that there could be this region which is uplifted, and there could be because of that a coast will be formed. So tectonic activity can also form this kind of depositional plain, but the main thing is it is formed by deposition, as we saw over here. Then there is this wind deposition plains. So we have seen wave deposition, we have seen glacier deposition, we have seen river deposition. Now here is wind deposition, and these are the sedimentary rocks which are formed on the surface. Remember, most of the sedimentary rocks are formed in the water, but this is formed on the land. So these are eoline deposits, loess. These are sedimentary rocks. They will form sedimentary rocks. The wind carries fine sand dust from deserts to far off lands. Continuous deposition forms loess plateau, and the example is northwest of China. So here is an example of loess plateau. So sand is carried from the deserts and it is deposited in the region where the wind becomes weakened or their velocity decreases. So they will start depositing it over here. Over the time, we will see that a layer of these sands have created a layer of rock. They have formed a rock because of coalescence, because of the pressure of the overlying layers. Loess plain is formed of deposition in depression. Generally, they are formed when there is this depression. So the wind will deposit in those depression. In this depression, these sands will be collected over time. Pampas of Argentina also has some regions which are created by loess plains. Loess plains are generally fertile. So they are generally fertile because they are very fine particles. Now, erosional plains. So erosional plains, as the name says, are created by erosion. Here we can see an example. This is a mountain, this is a valley. Over a very long time, the mountain will be eroded, maybe by glacier, maybe by rivers, but the fragments or the sediments which are eroded from here will be deposited over here, and you will see an almost plain region is created. So erosion creates plains. It can also create plateaus. So for example, if this was not deposited here but carried away somewhere else, then this would be like a plateau, a tilted plateau in fact. Plains carved by agents of erosion in millions of years can convert mountains into plains. Peneplains, a low relief plain formed by protected river erosion, also called plains of denudation, created by gradual weathering of land masses. So peneplains are low relief. Low relief means they have very low slope. Here we can see the slope is very low. So low slope region which are formed by river erosion, also called plains of denudation. Denudation means again removing the landforms of the region, that is denuding those regions. So plains of denudation, that is, it is formed by denudation, created by gradual weathering of land masses. Rivers also erode the highland spurs, creating gorges and canyons. So even in the upper course, the rivers will create vertical erosion and it will form gorges and canyons. Again, we will see all these things in much detail in the upcoming chapters. So now we are seeing the glacier erosion. Glaciers erode the underlying region of the regions to form plain areas. Here we can see this blue color is the glacier, this is the mountain, and this is how it is eroding this region. It is plucking the fragments of the underlying rock. So over the time, this region will be lowered and a plain region will be created. Ice-scourged plains are seen in Canada, Finland. Finland has around 35,000 lakes, 10% of the total land of the country, and these are formed by glacier erosion, something like this. Hollows formed by glaciers, they are filled with water to form lakes. So when these are plucking the rocks from the underlying rock, what will happen that there is some softer rock layer and more of the rocks will be removed. So a hollow will be created in that region and water will be filled when the glacier melts away. Remember, all this area, this Canada and Finland, were completely covered by glaciers in the Ice Age. Now, when the temperature of Earth evolved and it went higher, the glaciers, they went back. So we can see very good example of very rich source of glacier erosion in Canada and Finland, or those regions in the higher latitudes. Again, there is this erosional plains which are formed in the arid regions. Here, wind is the main erosional agent. Wind deflation carries away debris and sand. So because of this wind, in a deflated region could be formed where the sand has been carried away, lowering the area, forming the plains. So because sands have been carried away from a very vast region, a plain region could be formed. Then there is this mechanical weathering in arid and semi-arid regions where mountain blocks, where back mountains slopes. Wears back mountains. So wears back means mountains are there and they are worn back. That is, the mountains which are there, they are slowly worn away. Form pediment or pedeplains. So what are pediments? So you can see this is the mountain and here we can see a sloping structure, slight sloping region is formed over here. This is called pediment. Remember, pediments are not deposits of erosion, but they are basically the rocks, but they have a very gentle, very smooth slope like this. So they are on the foot of the mountains and they have very gentle slope. Form pediment or pediplains. So pediments, when a large number of pediments are there in a region and they just connect with each other, then they form pediplains. Pediment relatively flat surface at the base of the mountain or as mountain with no associated mountain. So it might occur that over a time whole of the mountain may be eroded and only pediplains or pediment you can see. So here you can see that there is only pediplain, mountains have been eroded away. Coalescence of multiple pediments. So it is basically coming together of large number of pediments that creates the pediplains. So remember, pediments are gentle sloping regions at the foot of the mountain, while pediplains are collection or large number of these pediments which are combined together over time. With this, we will conclude our video on the chapter 2. Please let us know in the comments how did you like this video and what could be the improvements. We are currently conducting this experimentation with online streaming. So please let us know how was this stream. If you have any feedbacks, we will like to know. Thanks for watching the video and do let us know your observations. Thank you.